Okay, good day to all of you. So in this video tutorial, we're going to learn how to convert a hexadecimal number system to a binary number. So hexadecimal is base 16, so it means it has 16 unique digits. Hexa means 6 and then deci means 10. So 10 plus 6 is equal to 16. So it has 16 unique digits starting from 0 to 9, the same with decimal. The only difference with decimal is that hexadecimal has letters from A to F with numerical values as follows. A is equal to 10, B is equal to 11, C is equal to 12, and then D is equal to 13, E is equal to 14, and then F is equal to 15. And then, of course, binary number is composed of two digits, 0 and 1. So that's why it's base 2. It's only composed of two digits, 0 and 1. So, how does hexadecimal and binary number fare with its conversion? Actually, it's very easy because, as we can see with the base, we have base 16 and base 2. Both are powers of 2. So, because of that characteristic, the conversion between this number system is easier compared to other number system, and especially if it is converted into decimal number system, which is not a power of 2. The base 10 is not a power of 2. So let's have an example. So we have a hexadecimal number. So we have DA0F13, CBE 5.9, A76, FE3, 1. Base 16. So this is our example. So how to convert it is very easy because if you memorize the equivalent um, hexadecimal to binary equivalent, hexadecimal for binary is composed of 4 digits. If you memorize the values, so it's very good for you. But if you don't, you can derive the table. So we have 16 divided by 2 is 8. So we have to have 8 zeros and 8 ones. So we have 0, 0, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. So we already have 16. Next is 8 divided by 2 is 4. So 4 zeros and then 4 ones. So 1, 2, 3, 4, 1, 2, 3, 4, 0. Let's repeat it. And then 4 ones. 1, 2, 3, 4. And then we have 4 divided by 2 is 2. So we have 2 zeros and 2 ones. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And then last is 2 divided by 2 is 1. We have to put alternating zeros and 1. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, and then 0, 1. And then let's put the equivalent value. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So 10 is for letter A, 11 B, 12 is C, 13 is D, 14 is E, and then 15 is F. So is the values correct? So again, let's have put the weights on these columns. So example, if we have 11, so let's just look the values with 1. So the values with 1 is 8, 2, and 1. So let's just add 8 plus 2 plus 1 is equal to 11. So this is the table for the conversion of hexadecimal to binary. You have to represent every letter with 4 digits of zeros and ones. So D is, okay, we have 1, 1, 0, 1. A is 1, 0, 1, 0. Then 0 is 4 zeros, 2, 3, 4. F is 4 ones. and then 1 is 0, 0, 0, 1, and then 3 is 0, 0, 1, 1. C is 1, 1, 0, 0, and then B is 1, 0, 1, 1. So let's continue here. E is 1, 1, 1, 0. 5 is 0, 1, 0, 1. Point. Okay, 9 is we have 1, 0, 0, 1. A is 1, 0, 1, 0. 7 is 0, 1, 1, 1. 6 is 0, 1, 1, 0. And then F is 4 ones. And then E is 1, 1, 1, 0. And then 3, let's continue it here, is 0, 0, 1, 1. And then 1 is 0, 0, 0, 1. Okay, we have no leading and trailing 0. So this will be our answer. So let's just review. So this is 13, 10, 0, 15, 1, 3, C, 12, 11, then 14, then 5, then 9, 10, 7, 6, 15, 14, then 3, and then 1. Okay. So this will be our answer. So actually, if you're confused, you can group it first by 4. But always the final answer, there must be no spaces. So this will be our final answer for this example. Okay. So if you don't memorize, you can look at this table. But of course, um, it's easier if you do it. But of course, if you really memorize, it's very good, but it's not required. As long as you know how to derive the table so that you will not be lost. So let's have another example. So we have, okay, so example is we have 2B7A 4E 0F 5 point 6CD1F 298 base 16. Okay, so again, let's convert. So 2 is 0, 0, 1, 0. B is 1, 0, 1, 1. 7 is 0, 1, 1, 1. A is 1, 0, 1, 0. Then 4 is 0, 1, 0, 0. And then E is 1, 1, 1, 0. And then 0 is 4 zeros. 1, 2, 3, 4. And then F is 4 ones, and then 5 is 0, 1, 0, 1. Point 6 is 0, 1, 1, 0. C is 1, 1, 0, 0. So let's continue here. D is 1, 1, 0, 1. And then 1 is 0, 0, 0, 1. F is 1, 1, 1, 1. 2 is 0, 0, 1, 0. And then 9 is 1, 0, 0, 1, and then 8 is 1, 0, 0, 0. So let's just check again. So we have 2, 11, 7, 10, 4, 14, 0, 15, 5. Then we have 6, 12, 13, 1, 15, 2, 9, 8. Okay. So this is not yet the final answer because we have to remove the leading and trailing zeros. So let's remove this leading and trailing zero. So let's just erase. So our leading and trailing zero. We have to make sure that for the integer part, the starting number is 1, and also the number for the fraction part will also end in 1. So this is already our final answer. Okay. So let's put base 2 since this is a binary number, and then this is our final answer. So if you're complaining why the example is too long, it's because the conversion is easier compared to others. So You just need to concentrate and, of course, if you memorize or look at the table. So this is the equivalent binary number for this given number. So um, as you can see, it's very easy to convert hexadecimal to binary because the basis of this number system are both powers of 2. So if you have any questions or comments, so please feel free to type or give your comments below, and then please don't forget to like and subscribe to my YouTube channel. So thank you very much. Good day and stay safe.